Hi there and welcome to lesson 7 of our final chemistry topic, C6, Chemistry Out There. Now today we're going to be looking at fats and oils. Now the main difference between a fat and an oil is a fat is usually a solid and an oil is usually a liquid. Now we're going to be looking at saturation and unsaturated fats and oils, and we'll also be looking at some of the reactions of those fats and oils. Anyway, I'll see you at the end. Bye bye. So let's have a look at our objectives for our lesson on fats and oils. So by the end of this lesson you should know and understand the chemical properties and reactions of fats and oils. Fats and oils occur naturally. They have a chemical functional group known as an ester group. Now, natural fats and oils can be found in plants and in animals. Some examples of animal oils can be lanolin, lard and tallow, whereas plant oils include olive oil, rapeseed oil and maize oil. Now, fats and oils can be both saturated and unsaturated. Now, saturated oils means that all the bonds between the carbon atoms are single bonds, whereas if they're unsaturated, it may contain at least one double bond between two of the carbon atoms. Now, a very simple test to see whether you have a saturated or unsaturated fat or oil is to add bromine water. Now, bromine water has an orange colour. Now, if it's saturated, then the double bond, if it's unsaturated, the double bond will cause the colour of the bromine to disappear. So we can see in this diagram we've got decolorized bromine water, meaning that this oil will be unsaturated, whereas the saturated has all single bonds, so the bromine water cannot attack and it will maintain its orange colour. Now, if we return to our animal fats tend to be saturated, whereas our vegetable oils tend to be unsaturated. Now, this means that our unsaturated oils are better for us in terms of our health, and that's because a poor diet will cause an uptake or build-up of cholesterol. So it is therefore better to have more vegetable oil which are unsaturated than it is to have this saturated fats in your diet. Now, you're probably aware that oil and water don't mix. And you can see in this diagram that the water sinks to the bottom and the oil will float to the top. Now, even if we were to shake the oil and water mixture, it would start to mix, but then would gradually separate out. Now, we can actually mix this together, and what we get when it's very, very well shaken is an emulsion. So where we have the shaken mixed vegetable oil and water, it's an emulsion. Now, that's because the shaking causes all the oil particles to break up and they will disperse within the water. So we get a spreading out. Now, we can get dispersion with an emulsion with two types. For example, milk can be or is oil dispersed mainly in water, whereas butter is water that is dispersed in oil. Saponification is where you are able to break up vegetable oil to make two products. Now, the way we do this is with sodium hydroxide, and we have the reaction for that here. So our fat and oil added to sodium hydroxide will make two products called soap and glycerol. Now, the soap is what's known as a fatty acid, and it's the long chain that connects to the end part, which is a glycerol. So if we have a look at our fat here, so this is our fat or our oil. Now the red lines are the fatty acid chain and the yellow block is the glycerol. Now what can happen is the fatty acid chains become separate, and that is our soap, and then we get our glycerol formed. Now this reaction is an example of a hydrolysis reaction. Now fats and oils are extremely useful in various different industries. Margarine is made from vegetable oil, which is an unsaturated fat, and it reacts with hydrogen using a nickel catalyst. That makes a solid saturated fat that can be blended with other materials so it looks and tastes like butter. There is also a lot of research into biofuels and biodiesels at the moment, and fats and oils are an important raw material for this. And this is where vegetable oil can be converted into biodiesels, and that's by reacting them with an alcohol catalyst. Okay, so that comes to the conclusion of our lesson on fats and oils today. We have looked at the difference between saturated, which means there are all single bonds between all the carbon atoms, and unsaturated, meaning it contains at least one double bond. We've looked at the tests for the two by adding bromine water, which will decolorize if it's unsaturated. We've also looked at mixing oils with water, so we can have things like milk, which is oil in a water, or we can have butter, which is water in oil. And then we've looked at saponification, which is the hydrolysis of fats and oils using sodium hydroxide. And then we've looked at some of the industrial uses, such as producing margarine and biodiesels. Anyway, I hope you've enjoyed this, and I'll see you next time. Bye bye.